Hello everyone, welcome back. Welcome to MindMatrix. So in this video, we will be proceeding further with the next question. I hope you like the question we have done in the last of our video. Okay, so we will be proceeding with the questions I have already shown you. So let's start with that. So here is a quick intro about me. You already know, we have seen this if you are following me, for long enough. And yeah, so this is like the last slides we have used. So this was the question we have already done. So like just to give you a brief overview, we spent nearly 30 minutes on this question. And why was it so? Because the question needs some kind of understanding. Unless and until we try to learn how to get what question is trying us to tell and what exactly needs to be solved, we won't be able to get the final answer. And that's what we spent the time on in our last session. Okay, that what exactly was my sample space for this probability problem, what was my exactly event, what exactly needs to be found, and how we are finding the conditions required. Okay, so if we solve that question again, so we will be able to solve within 5 minutes. It won't be taking much time. We just need to be aware that how we need to proceed further. Okay, so this was the question and you have already solved it. So let's come to the question which we will be dealing with in this session. Okay, so let's talk about this question. So we will be understanding the question first and then we'll start moving further. So the question says, a rod of length L is tossed at random on a plane that is ruled with a series of parallel lines at a distance 2L apart. Okay, so here is a thing. Okay, let's write the information first. The first information is we have a rod of length L. We have a rod of length L. Okay, that is important. Rod of length L. Okay. The second thing is we are having a kind of table. Okay, we are kind of having a plane, or you can say, okay, like, because we are throwing a rod somewhere. So let's suppose that we are having kind of table, or that can be floor as well. But on that we are having on the plane that is ruled with a series of parallel lines. So like the plane consists of parallel lines. Okay, something like this. There are parallel lines. So I am creating dotted line just to make you understand, okay, that there are parallel lines present, and all of those parallel lines are at like unit distance. Sorry, at the distance of same length. Okay, and that is also given to us, which is 2L apart. Okay, so if I just magnify any one of the portion. Okay, if I just magnify one of the portion, okay, let's suppose something like this. Okay, so what I'll be having, I'll be having something like this. Okay, so I'll be having, let's suppose this is the line. Okay, yeah, this is the same. Okay, I'm getting some issue over here. Yeah, so let's suppose this is the first line I'm having and this is the second line. I'm talking about, let's suppose, this particular portion. Okay, these two lines I'm talking about. This was there, no? So I'm talking about this. Okay, because there were a number of parallel lines, so I'll just pick one pair, and it is being told that the parallel lines are at a distance of 2L distance. Okay, a rod is already given which is having length L. Okay, L, and the distance between the parallel lines which are present on this kind of plane or a table or a floor, whatever you want to consider, that is 2L apart. Okay, now similarly, like, okay, these are like a number of parallel lines are present, something like this. Okay, and this is a big plane we are considering. Okay, if I just magnify this, so something like this would be present, something like this. Okay, I hope you're getting my point, what I'm trying to say. So there is a table which can be like a plane. So there is a plane which can be a table or a floor or something like a simple surface we are having. Okay, and you generally have on the flooring you have the patterns and something like that. So just similar to that, we are having something like this, and it is being said that, okay, the distance between these parallel lines are nothing but 2L. Okay, I hope the point is clear up to this point, because next we will be considering what exactly the question is asking us. Okay, so now it is being told that, okay, we had the rod of length L. Okay, So it, because if I'm considering this much to be 2L, this much to be 2L, so it's like something like I'm having this long enough. This is my rod of length L. This is my rod L. Okay, this is the rod I'm talking about. So if I pick this rod up and then just throw it on the surface or a plane, so it may land like this, like this, like this. There's so many orientation that how it can land on this surface. There are so many ways it can land. Now the point is, the question is being asked that what is the probability that this rod will intersect any one of these lines, that this rod will intersect one of the lines. So whatever examples I have given you over here, this, no one is intersecting with any of the lines, but I can have something like this, or maybe something like this. If my road completely lies on the line, that is also one of the possibility. Or it can be something like this, something like this. We are just throwing that rod and then it is just lying on the table. That is just completely up to the situation, that how it is landing on that. It can be like this, it can be like this. Like there are so many ways out there. Okay, so we need to find out the probability of this rod intersecting with one of these lines. Isn't it a good question? You might be like curious, okay, how it is going to be solved. And the other point is this question important from the gate point of view? Let me tell you again that this question does not require any higher level mathematics apart from the basics. And the other thing which you must be knowing, like I guess if you have studied engineering, you have heard about polar coordinates as well. You have heard about polar coordinates as well. Okay, as we have like what should I say, xy. So similar to that, we have a concept of r theta. Xy is like when we have the coordinate exactly that x point, y point. And sometimes we have polar coordinates where we are given the distance from the origin and the angle it forms from the origin. Okay, so polar coordinates, if you know that, then you can solve this question. Okay, the thing is how much you can think about the problem. Okay, that is it. So this is very really interesting problem out here, and if you can solve this, then you would be able to solve the questions based on basic probability, because I won't be using, again mentioned in the last session also, that we have used only basic probability. We haven't introduced Bayes theorem or random variable yet. Okay, so if you are liking this question, if you like previous session, so do give this session also a thumbs up. We'll be solving this question over here within this video. Okay, and do comment that how are you liking these kind of questions. Okay, so let's understand. So I guess the understanding of this question is clear. The understanding at this point is pretty clear, that how and what is being asked over here. Okay, so let's see this now. So yeah, I'll just clear everything now. I'll just come to the point what is required over here. So the thing is, let's just talk about that only, what is required. So let's say something like this. So just to clear a bit, I'll just talk about this thing only, that if I just throw a rod, so there would be any set of parallel lines always, like there can be 2, 3, 4 n number of lines, but I'm saying that when I'm throwing it, it would be in between them. It would be in between them, because there can be like enough number of lines are there. So I am not considering that, because for every, if I just consider one parallel line, that what is the chance of having an intersection with that. So that will be giving me an idea that okay, what are the chances. So I'm just picking up this pair, and from this also I'll just move on to only one parallel line. So the thing is, we already know these two lines are 2l length apart. The point is, these two parallel lines are 2l length apart. Okay, and my rod is what is the length of my rod? That is just L. That is just L. So just think about this. Just think about this, that should I consider the problem that okay, my rod will be intersecting with both two lines at a time? No, it won't be happening at any point of time. My rod would not be intersecting with 2, 3, 4 lines at a time. That won't be happening. It will intersect with only one, because we already know the total distance between two is 2l, and the length of my rod is itself L. If you, even if you just, just try to touch both the lines and you just make it in a vertical position at a 90-degree, even then it won't be reaching to the other line which is there. Okay, it would just touch one, or it can be something like this also. Still it is still it is L. Okay, and it is neither touching any one of the lines above and below. Okay, so I guess up to this point this is clear that okay, if we have two lines we consider, even then my rod will be intersecting only one. So what can be the possibility? So either my, rod can be something like this, or it can be something like this, or it can be something like this, something like this, 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 so many. Again, okay, we are just creating different scenarios for you to understand. Now the point over here is we will be considering line closest to the road only, closest to rod only for intersection, okay. Why is it so? See over here. So if I just talk about these, this is the one which may be, and this is these two, and this is, yeah, this is the same one. So let me just, no, just increase its length a bit so that it seems that this one is closer to this. Okay, so this may seem that it is equidistant from both of the lines above and below. So I can consider any of the line for this kind of orientation. Similarly for this, okay, and if I talk about this one, so I'll be considering only this line, okay, for the intersection. If I talk about this, because this is being closest, I'll talk about this line, again talk about this line, for this talk about this line, for this talk about this line, for this talk about this line. And how do I decide that? Simple, just talk about center of my rod, to whichever line it is closest, I'll talk about that only. Okay, because for other the probability would be 0, because we can just see that. So for any intersection I have to talk about only the nearest line always, otherwise there is no intersection. I'm sure about that. Okay, because we know the length is also not too big. Okay, so it will always be intersecting to one line at a time. So we'll talk about one line only, and that one line would always be the one for which it is closest as compared to the other lines present. Okay, so how do we decide that? Based on the center of my rod. So you can see over here, let me just mark the centers of these by red point. Okay, so this was the center, this is the center, this is the center, this is the center, this is the center. Because I just, extended it, let's say this was the center, so it was below this center line, it was below the center line, because this is 2L, so you know that this is L and this is also L. Okay, combinedly 2L. So this this rod is its center point is below the center of this line. This is the center point, this is the center point of this rod, this is the center point. So now you can able to identify that, okay, what are the center points closest, okay, sorry, what are the lines the rod is closest to for each of the orientation I have put over here. Because we can throw away the rod in any, like, okay, in any way, and it can land in any of the orientation possible mentioned over here. Okay, in fact that is also possible that it can be like horizontally coming there. Okay, something like this, that is also a possibility, that it lies something like this. Okay, completely overlapping or completely overlapping on the center line, that is also one of the possibility. We have to consider all of these. So you can see which of these are intersecting, which of these are not. This is intersecting, this is intersecting, this is intersecting, this is intersecting, not others are intersecting. And if I consider this to be rod, then it will also be touching at this point. Okay, so this is also intersecting, considering this to be the center point of this rod I'm talking about. Okay, so now up till this point every idea is clear. Now earlier we were talking about a number of lines out there, and we are throwing the rod in any of the possible way, and then we were discussing about the orientation. Now we have reduced it to considering only one line, and then talking about the rod, that how it is landing and how it can intersect or not. We'll talk about that only. Okay, so as mentioned, we'll talk about only that particular line which would be closest to my rod. So whenever there will be confusion, like for this one or for this one, What will decide? Will decide any one of these, okay, and that would be enough for my problem consideration. Okay, so up till this point everything is clear, I guess. Okay, we have given enough of time to this. Okay, so now I have converted this problem to only single line, and let me just draw that now. So now I'm saying that this is my line. Now I'm saying that this is my line, and my rod can be in any of the orientation. Let me just show you how it may be. So let's suppose, because I'm considering the, because I'm considering my rod to be in any orientation, and I'm always considering the line which is closest to the center. So let's suppose this is the center of my rod, okay, and there can be n number of orientations present. Let me just show you. Okay, let me just show you. So my rod can be like this. My rod can be like this. My rod can be like this. There are so many possibilities out there. Okay. Okay. So I hope the idea is clear. And this is the center, the point marked by red, that is telling me the center of my rod. So I have shown you, three orientation of rod. So there are not three rods present over here. I'm talking about that the rod can have, horizontal, slant orientation, this or this, or it can be vertical as well. Like right now, I'm just showing three orientation for you to understand. Okay, there are only three orientation I'm discussing about right now. Okay. Now the thing is, I'm telling you that I will always be considering the center point of my rod. Let's suppose the distance of my center point from the nearest line possible is r. What I'm telling you, let's suppose this is r distance. Now what is this r? What is r? R is distance of closest line from center of my rod. Important. Okay, this is important. So r is my distance of closest line from center of rod. Okay, now this is clear. Now you can just tell me what is the range of r possible, what is the value of r possible, what is the value of this distance possible. So you can see in whatever position you put it up, the maximum distance possible is always L, and minimum distance possible for R is 0. Okay, when the center point comes on this line, then the distance is 0. Okay, and when I'm talking about, okay, what can be the maximum distance, then it can go up to L. This point, okay, that center is coming over here, then I'll say the maximum distance is L. Why not greater than L? Let's suppose the center goes beyond this. So will I be considering any distance greater than L? The answer is no, because in that case, that rod will be closest to the above one, and the distance for that point would be lesser than L in that case. So I hope the idea is clear over here, that why maximum distance is L and why minimum distance is 0. Minimum is when center is lying on my line, okay, and maximum is when my center lies on the center of these parallel lines, exactly in between these parallel lines. Okay, because even if I, let's suppose I say that, okay, my rod was more than L away, let's suppose something like this, that my center was present over here, so it may be greater than L, as this is this distance we have already seen, this is L, so this distance may be greater than L, but I have talked about that rod must be closest to the line I'm talking about. So in that case, this would be the line I'll be considering, because this distance is lesser. So for this one, the distance would become less than L. Okay, so I hope the idea is clear. This is the important point. First point. So we have talked about R, which is the distance of closest line from center to rod, from center of rod. Okay. The other thing is, we have talked about the distance. Now we'll talk about the orientation. There are multiple orientation possible over here. Okay, so let's consider that now. So what can be the color I can pick up? Yeah, white is good. So if I talk about this one, orientation will be telling me the angle makes with the horizontal or with the line or like horizontal axis, because I'm considering horizontal axis to be parallel to my lines which are present. So I'm telling you that okay, I'll be talking about this angle theta. This r and theta is enough to tell me that whether my rod will intersect or not. This r and theta is enough to tell me that whether my rod will intersect or not, and r and theta will also tell me that where exactly and which orientation my rod is present, exactly where and in which orientation it is present among between any two parallel lines. Okay, so like for an example, for this orientation I have made this theta. If I talk about this, so theta is 0 for this, like with respect to this, like this is the axis, so along it this rod is present for this, so angle is 0 over here, 0. It must not be looking like theta. Okay, if I talk about this one, so again I'm considering this to be theta as well. So this, theta is less than 90 degree over here, theta is greater than 90 degree over here. Okay, and this is 0 over here. And if I say it is like completely in this way, then in that case my theta will be 90 degree. Okay, so I have talked about enough thing, like okay, my rod can be like this, it can be like this, it can be like this, this, and then again this. So these are the overall orientation which can be present. You can see this. Okay, if I just throw a rod on a table, so these are the kind of orientation I can have. So that means my theta over here will vary from 0, because theta can be, minimum value can be 0 and maximum value can be, it's not 90, it's not 360, it's pi, that is 180 degree. It's pi 180 degree. Why not? See, so let's just talk about this. So I have just, this was like this, and then when I made this, so it was like this. So okay, maybe I don't know, like for you, like whether it is the same orientation I'm talking about or not. So it is like this, and then when I talk about this, vertical is this, and like this. Will I go beyond this? So if I'm going beyond this, it would be like this. So it will be coming same with respect to the first one. Then like after pi, it would start repeating the orientation. Okay, so my overall value of theta or the angle would be between 0 and pi, that is pi means 180 degree. Okay, I hope this idea is also clear. So we have got two things over here, r and theta, which tells me exactly the position and orientation of my rod in between two parallel lines, or basically the distance, or yeah, basically orientation and position with respect to any of the parallel lines present. Okay, and as mentioned that we will be talking about only the parallel line which is closest. Okay, so that will be telling me that okay, how my rod is placed to the closest line. Okay, these r and theta will tell me that. So up till this point we are clear that how this rod is working over here. This point must be clear. Now the next point is, after understanding all this thing, that okay, I have the understanding of my orientation of the rod. The next point comes up is problem now. That what is being asked and what are we having. So now for calculating the probability of intersection, so you just tell me, as I have talked about this, that not every orientation or position of my rod will lead to the intersection with any of the parallel line. There will always be some orientation or position of my rod which will lead to the intersection with the line, and I have to find all those numbers divided by total number of ways in which this can be there. Okay, in which my a rod can be present. So if I talk about closest to one line only, what are the total number of ways possible it can be there? It can be positioned in an orientation. What are the total number of ways? So that is given by this condition and this condition. So now this was something which I was talking about, the polar coordinates kind of thing. Okay, so if you just talk about this, if we discuss this thing simply, so we are having two quantity, one is r, one is theta. Okay, one is r, one is theta. We have a range for both of these. Okay, and we need to find out the total number of possible coordinates, and like in the next previous session as well, when we were looking for number of triangles is possible over there. So for an example, if r is L by 3 and theta is something like pi by 3, I don't know whether it will be intersecting or not, but yeah, this is one of the orientation I have got. This is one of the orientation I have got, that pi by 3 is telling me that there is a 60-degree angle, 60-degree angle which is being formed, and L by 3 tells me that this distance is L by 3. I know this. Okay, so this is one of the position I have got. Similarly, if I say okay that it is like 2 pi by 3, something like this. Okay, so what is this? This is 120-degree, and if I say that the r value is given to be 2L by 3, then it means something like this. My rod is in this orientation, 120-degree angle. Okay, and the distance from the closest line is nearly 2L by 3. This distance I'm talking about. So I hope the idea is clear, that with the help of r and theta I can get any orientation I want. Okay, now among these orientations, some orientation will be there which will be intersecting with the line. Okay, so for the sample space, you know what we will be doing. For the sample space, what we will be doing, we will just find out total number of points present. Okay, in which it can be present in any kind of orientation which is there. So what is that? That will be simply like my r varies from 0 to L and my theta varies from 0 to pi. So what are the total ways? So if I just show you in this way, that okay, my theta is like this, 0 to pi, and my r goes from 0 to L. So we need to find out this number of coordinate. Yes or no? We need to find out the number of coordinate, the number of pairing possible for r and theta. And how do we do that? We won't be counting each of the coordinate. We can simply find out the area of that region. So if I know that, okay, my vertical distance maximum is r, basically height of my rectangle is r, breadth of my rectangle is pi or theta, then I can find out this area. What is that? That is simply r into theta would be my area of this thing. And what's the sample space size then? The maximum value of r is L, so 0 to L, into what is the maximum value of theta present? Pi, 0 to pi. Okay, is the range. So I get the samples area of my sample space. Area, sample space means basically the points I'm having, I'm considering all that. So that will be equal to area of this region. Okay, sample space is nothing but area of this region. Area of this region I have mentioned, and that is L pi. Up to this point, your idea of sample space must be clear. Idea of sample space must be clear. This is important over here. Okay, if this is clear, we can proceed further. Okay, let me just repeat it. We have enough number of orientation present which may or may not lead to some kind of intersection, and orientation can be identified using two parameters. One is r, which is the distance of closest line from the center of the rod, and theta, which is the angle it makes with my horizontal line. Okay, if I combine two, I will always be having a unique orientation possible. Will all those unique orientation lead to intersection? The answer is no. Okay, so for the sample space, if I talk about that, how many orientations are possible? So we have the range that for r, it must be from 0 to L. For theta, it must be from 0 to pi. So I get the total number of ways it can be there by simply calculating the area of the shaded region present over here, which is nothing but L pi r into theta. Okay, that's what we have got up to this point. Now I will talk about this thing, that intersection must be happening. So I'll just erase now these kind of orientations over here. I'll just keep this one over here. I'll just remove this. Okay, so okay, I'll just remove. I hope every idea is clear. You have drawn it properly. Okay, so there will be two ways I'll be telling you that what is the condition required for the intersection. Okay, there are two ways we can talk about that. So these are the things which are important. I'll just keep it. Let's just talk about that. Let's just talk about that. Let's talk with white. So yeah, let's see now how we are going to decide whether the rod will be intersecting or not. So this is my line, and let's suppose this is my center. This is my center. I don't know the length right now. I don't know. Basically, okay, let's just decide that as well. Okay, and let's say yes, this is long enough. Okay, and I know it is not intersecting right now. I know it is not intersecting right now. So this is my rod of length L. This is my rod of length L. Okay, and let's suppose this is the R distance I'm having. Okay, I know I'm not able to create straight lines over here, but kindly pardon me for that. This is R, and if I talk about just this and I just extend it, I'll get this as theta. I'll just get this as theta. Now the point is how we can decide that it will intersect or not. There is a simple thing. Okay, we'll just do simple mathematics. So what is this thing? So let me just mark this point O, A, B, and over here the intersection point, let it be C. Okay, so you know already it is like OA upon OA upon AC is equal to sine theta. Yes or no? We know this basic mathematics. We know this. I'll tell you why we are doing this, because we have to find a relation between R and L. Okay, that in terms of L, whether I can tell what must be the distance R. In terms of L, can I tell what must be the distance R? Because then only I'll be able to tell, okay, that there will be intersection or not. So I know OA upon AC is sine theta. And what is OA? OA is my R. And what is AC? AC is my hypotenuse. Let's say this is hypotenuse. Okay, equals sine theta. And hypotenuse, hypotenuse becomes R by sine theta. And now just tell me what must be this length of hypotenuse to ensure that there is an intersection. Just think about this. What must be this value of hypotenuse to ensure that there is an intersection of this line? Simply, I know that, okay, this was L now. So from this to this, I know AB is already L by 2. I already know AB is L by 2. So if I wanted that B is not present over here, B is present over here, or B is present somewhere after this, because then only there will be an intersection. No? If this is the A point, I want to ensure that there is intersection. So B must not be present over here. B must be present over here, or just after that. What I mean is, let me show you the orientation. It can be something like this. A was present over here, and then B is present over here. Something like this I'm talking about. Okay, this is R I'm talking about. So to ensure the intersection, my B either must be present on this line or it must be below this. What does that means? That my hypotenuse must be less than equal to L by 2, because AB is this AB distance is my L by 2, half of my length. Okay, this is my L by 2. So I want my hypotenuse must be lesser than this. If I just simply decrease this AC size, then AB, if I just decrease this size lesser than AB, then I can ensure that my intersection would be taking place, because in that case my B end point will be either on the line or will cross the line. Just think about this. Okay, that if I can make sure for the intersection that B lies over here or B lies below this, like over here, then I can ensure that there is an intersection taking place. Okay, so what will I say? That my AB, which is L by 2, is greater than the hypotenuse which is possible. AC. Okay, so hypotenuse must be less than your L by 2 distance. It must be less than L by 2. So what I can write over here, because H is R sine theta, that R sine theta, which is hypotenuse value, it must be less than L by 2. So I get this, that my R must be sorry, it was, I guess I made some mistake. Yeah, it is not R sine theta, it is R by sine theta, to be honest. Yeah, there was a mistake. Let me just remove that. eraser. Okay, just wait. Okay, just see this. So h is r by sine theta, r by sine theta. So here also I'll just write it as that only. I'll just put that. So r by sine theta must be less than equal to L by 2. That means your r must be equal to L by 2 sine theta. Sine theta is in denominator of r. So r must be less than equal to r. L by 2 sine theta. This is the condition for intersection. This is the condition for intersection. Can I get it in some other way? So this was one of the basic idea using simply, trigonometric stuff, by creating triangle and then understanding, and we got this. The other way we could think of it was that whatever is this AB line, if I take a projection on this vertical line, whatever is this AB distance, if I take a projection on this OA line, then always for the intersection, always OA must be less than projection. OA must be less than the projection. Basically, I'm talking about AB dash. This is AB. If I just project it on the OA line, then I'll get AB dash. So what I'm talking about is, for the intersection, my projection must be greater than OA. Yes or no? Because if it is less than that, then okay, there is no intersection. But if it is something like this, where was this example? Yeah, this one. So that means if I just project on this one, then you can see AB dash is greater than my OA length. Okay. So that means if I can make sure that AB dash is greater than R. And what is AB dash? AB dash greater than equal to R will make sure there is an intersection. What is AB dash? Simply, if this was theta, this is also theta, and this is 90 minus theta. How do we take the projection? Cos of whatever is the angle. So because this was theta, this is 90 minus theta, the cos of 90 minus theta. Whatever is this length, AB cos 90 minus theta will give me the projection. So AB dash, let me just write it over here. AB dash is nothing but AB cos of whatever is this angle. Let's say this was phi. Okay, cos of phi. And what is phi? Phi is nothing but 90 minus theta. So overall, what do you get? AB is L by 2 and cos of 90 minus theta is sine theta. So that means L by 2 sine theta must be greater than equal to R. And that's what we are having over here. So I guess it is clear both the ways. So now I'll erase everything over here. Now I will erase everything over here except this part. Okay. I hope the idea is clear. Oh, that I can draw again. There is no issue with respect to that. Okay. So I hope the idea is clear with respect to the condition which must be there. That distance or R in terms of L, what must be there? L and theta, that what must be my distance, so that I can tell you that there will be intersection or not. Okay. And I hope we have understood it well from both the point of view. When I talk about this, and we just discussed that, okay, what must be for intersection, your AB length must be greater than your hypotenuse over here. Or the other way of talking about the same thing is the projection of AB must be greater than your OA length, which is R. Okay, this is one and the same thing. So let's move further. I'll just erase everything. We know already sample space is the area, which is like R theta. So what was R? 0 to L, theta was 0 to pi. So overall area was L pi. Now I'll erase everything and we'll get to know what is the, my desired area I'm looking for. So yeah, so let me just write for sample space over here. My sample space size, okay, or the area is basically, what is that? The sample space. That is simply the length of the sample space. If I talk about that is the area, and area was length of my sample space. If I talk about that is area, and area was L pi. This is capital L because it was mentioned. Okay. Now if I talk about the condition for the intersection, we have already learned it. for intersection, we already know the other conditions which were present. What was that? That theta must be 0 to pi and r must be 0 to L. That was already existing condition. But for intersection, we have another extra condition, which is r must be less than equal to L by 2 sine theta. R must be less than equal to L by 2 sine theta. This is the another condition we are having over here. Okay. So now you are having three conditions, and now you can find out the probability as we have found out in the previous question. So what is it going to be? Simple stuff. Now see this carefully. So you could see this thing when I talked about this, that when theta is like present over here and r was present, then it went up to pi and there was this L. Okay, and we discussed about this complete area. We said that okay, this complete area is my sample space. Yes or no? Just try to recall this. Okay, now if I talk about the event I'm looking for, so basically those points when I will be having intersection, so I know that is in the form of L by 2 sine theta. Okay, so now you know whenever I put theta, I'll get some r value. And for r must be less than that. So for any theta value, I'll find out what exactly is this point, and below that point only I'll be having those valid point. For an example, let's say theta is equal to 90 degree. If I say theta is equal to pi by 2, 90 degree, okay, 90 degree, then what is this quantity? This is a 1 and it is L by 2. So r must be less than L by 2. So this is like L by 2 if I consider. Okay, if I put theta is equal to 0, then r must be less than equal to 0, which is just 0. If I put theta equals pi, it is less than again 0. And if I put theta is equal to something like, okay, 45 degree. So, like, okay, the point is this is just a scaled version of sine theta. What is scaled version of sine theta means? That, okay, if you know that, graph of sine theta, you know how you will draw it. Because then you are just multiplying it by L by 2 fixed value, because L is fixed value and you are just multiplying it with sine theta. So what is the graph of sine theta? It is something like this, if you know. Okay, pi over here, pi by 2 in between, 3 pi by 2 over here, and 2 pi over here, 0. Okay, and we are considering only theta from 0 to pi, and we know the highest value present, which is L by 2. So it would be something like this. Sorry, I cannot erase that, but okay, it would be something like this only. Okay, and the highest point is basically L by 2. So those points would be responsible for the intersection which lies over here within this. Okay, within this region. You can just think about this. Within this region, whatever are the points, those will be responsible for your intersection. How? So if you consider theta to be, this one, whatever is this, then if r is less than whatever is this point or this point, then it will be definitely intersecting. And we know this because this is the criteria we have already filled. Okay. So now I think idea is clear that, okay, what are the points I'm going to talk about? So how do you find this area? Simple stuff, area under the curve. You can do that. How do you do that? So, so r is, based on this. So, like either you can go by simple method, which we have already, solved like in our lower classes. So what would be the area if you just consider small strip over here of length, d theta? What would be the, so let's suppose this is theta, this value is theta. Corresponding to that, I'm talking about d theta only, the width of this strip. What is the height corresponding to that? That would be L by 2 sine theta. So what is the area going to be there for this one? It is going to be L by 2 sine theta into d theta. Now you have to change theta from 0 to pi. You can go like this. Okay, or you could simply do that in another way as well, that is similar to you are having an equation in y and x. Okay, and you need to find the area under the curve. Okay, then what you'll do, you have this equation and you just do y dx. You know this. How do we calculate the and then there will be a range from x is equal to something like a to b. You know this idea, okay? And that is the same idea we are following. The x goes from 0 to pi. So what would be this area? L by 2 can be taken out, and then if I talk about sine theta, what is the integration for sine theta? That is minus cos theta, okay? And if you put 0 and pi value, what do you get? I'll just write it over here, L by 2, and because the integration is minus cos theta, so I'm taking minus out there, cos theta, putting value 0 and pi, what do I get? So for cos pi, the value is -1, for cos 0, the value is 1. So I'm already having minus L by 2 out. So cos pi is -1 minus, what is cos 0? Cos 0 is 1. What do I get? -1 minus 1 minus 2, minus 2 into minus L by 2. I get L only. I get L only. Okay. From here, I'll get -2. -2 into minus L by 2 is L only. So this is the area of this particular region. Okay. This is the area of this particular region. Now, what is the final answer? The final answer becomes this area upon the complete area. So probability is, what is this area? This was L. We have just calculated. And what was the area of this complete rectangle? That was L pi. L gets cancelled and the answer is 1 by pi. The answer is 1 by pi. I hope the answer is clear. I hope the method is clear. Okay. This is important. I hope the answer is clear. The method is clear. Okay. Properly. So I hope you have enjoyed this question as well. This was also an interesting question over here. Okay. From the scratch, we have built up the concept that how we can think about the probabilities over here. Okay. How do we calculate that? And this is again, I'm just, reminding you, there is nothing like random variable we have discussed. There is nothing like, Bayes theorem or conditional probability, joint probability, nothing like that we have discussed. It's like simple probability with some basic intuition about the calculus, and we can calculate. Okay. And because you are B.Tech graduate, most of you, and even if you are not, you are in your third year, then you should be able to understand the basic integral calculus. Okay. So I hope the idea is clear. If you like this video, do give me a thumbs up. Okay. Comment down how was this question, whether you liked it or not. And to be honest, these are not very difficult questions. These are just to, because what happens is sometimes there is a limit to our thinking. Okay. And what we have solved in our lower classes was not up to this mark. And this is not really a difficult question, I'll be very honest. It is just that we haven't reached up to this point earlier. So now when we are just reaching, it may sound difficult, but after solving it 2-3 times, you'll get to know that there was nothing, difficult within this. It was just the concept and or pushing your limit, or understanding the reasoning behind the question which was required. And if you are able to do that, then you are okay. You will be able to solve question in data science paper as well. Okay. So I hope the idea is clear. So we'll meet in the next session. Before that, this is the kind of homework you can do, though this was the homework question if you remember from the last session, but you can try both of these, especially this one. Please do try. This is the homework question. We will solve both the questions. We will solve both the questions in the next video. Okay, because this won't be taking much long enough time. The problem number 4. Okay, so see you guys in the next video. We'll be solving these questions, and I hope you have liked this video. Do share it with your friends who are preparing. And again, I should not be reminding you that again. Kindly do give a thumbs up, comment down. Okay, and this is the WhatsApp channel we are having, Telegram group you can scan and join, Instagram page you can follow us on. Okay, so see you guys in the next video. More of more detail are in the description of this video. Thank you guys. Bye bye. Take care. Thanks for watching.